Good afternoon. So we are Astrobotic, and we're all about making the moon accessible to the world. And I'm really, really excited to be part of the CLPS program and making the moon accessible to all of you. So fundamentally what we do, we are a delivery service. So we're like a DHL delivery service to go to the moon. Once we get to the moon, we provide power and communications. So we provide the services you need to operate your payloads on the surface. So we have landers, and we also have rovers. So we have landers of two scale. First lander that's going to be going to the surface of the moon is called Peregrine. Can take about 200 kilograms to the surface of the moon. We also have a larger scale lander called Griffin that can take on order of 400 kilograms to the surface of the moon. Peregrine flies as a secondary, Griffin flies as a primary, so we have control of launch and timing. We also have mobility platforms for mobile payload as a service. So if you have an instrument that wants to move across the surface, we can provide the platforms to make that happen. We have small platforms that we call cube rovers that can carry on order of 5 kilograms up of payloads across the surface. We also have a large rover called Polaris that is designed to pair with Griffin. That can take up to 90 kilograms to the surface of the moon and drive across the surface. So the Peregrine Lunar Lander is designed as a commercial delivery service first. So it's designed around the customer. It's designed to support your needs and your payloads that want to fly to the surface. We want to make the interfaces as simple as possible so we can take many different payloads up to the surface and make the interfaces simple so that the interactions between us are simple, and that's important for efficiency of the program. The lander can fly to any destination on the moon as long as it has communication and line of sight back to Earth or off a relay satellite. So we have configurations that can go to the poles just by simply reorienting the solar panels. We can take large rovers on even Peregrine by putting it on top of the lander. And ultimately, this is like the utility vehicle for the moon. This can land anywhere you want to go. The first mission is configured in a way that we can carry up to about 90 kilograms of payload to the surface of the moon. Payloads that come with us get an allotment of power and communications for the payloads that come with. So per kilogram, there's 10 kbps of communication, and there's also half a watt of power on average for the payloads that come with. So the idea is that you're provided the basic resources to operate your payloads on the surface. And those numbers scale as the kilograms of the payload goes up. So we've got a whole array of payloads attaching above and below the decks. So for instruments that might want to look at the stars and look maybe back home to Earth or look up, you'd want to be mounted on top of the deck. If you want to interact with the surface or drop and drive or just touch the surface in some way, you would be mounted on the bottom decks. And we have rovers, for example, that'll just mount there and drop right down to the surface. We have an array of missions planned going into the future. So the first mission is starting out about 90 kilograms, and we're going to be stepping up the mass as we go. It is the same vehicle that's flying on these subsequent missions. All we're doing is filling the fuel tanks all the way and operating a little bit closer to the margins of the spacecraft. So we're learning how to fly and making it better and better and getting closer to the operational capability. So we can get up to 200 kilograms of capacity to the moon. Future missions, we could potentially put 2 Peregrine landers on a single primary launch and go to 2 destinations simultaneously at the moon. So it could be very exciting. Steve just covered this, but we did win a $79.5 million contract to deliver up to 14 NASA payloads to the surface of the moon. Very, very exciting for us. It's been 12 years in the making to get to this point where we now have a manifest full enough to fly, and we're very, very excited about that. This is the list of our manifest for the first mission. And you'll notice NASA's 14 payloads is just one line here. And this is really exciting. This is the world going back to the moon. This is 8 nations represented on this first mission. Big companies, small companies, other space agencies, a whole array. We've got science instruments, exploration devices, technology demonstrators. We've got first steps toward infrastructure on the surface of the moon. All these are listed on our manifest page on the website. Just a couple ones to point out, though, that I think are kind of fun stories. The Mexican Space Agency, AEM, is flying with us to go to the moon. And they could be the 4th nation to operate on the moon after China because they're flying with us. And I think that's incredibly exciting to be a part of that story. Atlas Space Operations is setting up the first laser communication node from the surface of the moon. So that could enable orders of magnitude faster bandwidth capability. So instead of on order of about 3 megabits per second, we will see hundreds of megabits per second streaming directly from the moon. So all of the pieces are falling into place for some really exciting missions, and we're just building those building blocks up. We also have a few rovers flying on the first mission. We have a Cube rover from Carnegie Mellon University flying on the first one, as well as iSpace in Japan flying a rover. So lots of exciting opportunities here. We even have some marketing things to make the moon fun. You might say, oh, you don't want brands on the moon, but I actually think of that as opportunities to engage a wider audience. If you're engaged with large companies, they're going to use their marketing dollars to make it fun and exciting for the world to be a part of. So we're actually really proud of those partners that are flying with us to the surface. So we've been in development as a company for 12 years and been working on landers and rovers all throughout that. Right now, we are getting ready for our critical design review and ordering long lead items for our first mission. We also did a hot fire for our engine in about the last year. And we're on track and getting ready for a flight in June of 2021 for landing in July of 2021. So this mission does not happen without the great partners that we have accumulated and built up over the years. NASA Catalyst in particular has been a fantastic one. It's a great example of a very successful public-private partnership to advance the capability of industry and build up a platform that can one day be commercial and be sold to the world. Airbus is our partner for landing legs and also systems engineering. We don't make the assumption that we can fly to the moon and land all by ourselves. We need experience. We need folks that have been there and flown missions. And between NASA and Airbus, that provides us that experience to make sure we can be successful on the very first mission. Dynetics is our propulsion provider, and DHL is not just a sponsor, but also helping us with logistics of the mission in terms of transportation, making sure everything's where it needs to be at the right place, the right time. So we have some future service upgrades that I do want to make you aware of. So right now it's just delivery to the surface, but we do have some new capabilities coming online. The first mission is going to be testing precision landing. So we got a tipping point contract from NASA to help develop this capability. This will shrink our landing ellipse from about 6 by 12 kilometers down to on order of 100 meters. So for the folks that have specific sites of interest in place and in mind, we can go there on mission 2 and beyond. This will be a standard service for the second mission. So this uses lasers to do hazard detection when we get in close, and then we're using essentially cameras to look at the features and do terrain relative navigation as we're coming in to get precision landing. So we've done some cool. We have a 3D model of the moon, and we're able to simulate these landing sites, so you could potentially land at a place like this. Lots of challenging terrain, but we could potentially get this done. But this is actually real data from the moon that we were able to recreate and see lighting conditions. So these rovers, we've got mobility as a service. So same capability as the landers. So the landers have power and communications. The rovers will also have power and communications to provide for the payloads that come with. This is Polaris. This is our large-scale rover, 90 kilograms, currently configured for a polar region with the vertical solar panels. All of our vehicles are designed to be very simple, very few moving parts. We typically do a 4-wheel skid steer approach for the vehicle, so it drives like a tank. We do that for simple reliability. So fewer actuators, fewer places to fail. We just want to deliver and drive across the surface. This is our Cube rover. So this is our smaller scale vehicle. This would be a perfect match for the Peregrine lander, so it attaches to the underside of the decks, can drop and drive and go off into the distance. The Polaris rover, it can drive independent of where the lander is, so it can go kilometers and kilometers away from the lander. Cube rovers here have to stay close to the lander for now. The Cube rovers rely on the Wi-Fi network of the lander, so it has to have line of sight. It ends up being about 500 to 750 meters from the lander. In the future, when we have orbital assets to relay signals off of, these small rovers could potentially go beyond the communication line of sight with the lander. So just a few things to think about as you're formulating missions and formulating payloads into the future. So we've also looked at the poles, and yes, you can go to areas that are permanently lit or very close to, but you can also just smartly figure out where to drive when. So we've created maps of the sun, maps of Earth view, the critical resources that you need to drive around, And if you plan your routes correctly, you can actually call out different destinations at the pole and go here, go here, go here. And you can plan and say, okay, drive this fast to this point and then stop, and then crawl over to this point, go over to this point. And basically doing that smartly, you can stay in the sun and stay in communication back home to Earth. So it's a possibility to land in challenging polar destinations, but do pretty expanded missions to go to multiple science destinations. So all in all, when you're thinking about planning for payloads to fly on our lander, you can check out our website. We have our payload users guide listed right on the front page. It's PDF, and you can check out all of the interfaces and how the basics of the mission works. Once we get to the next step, we then have an interface design document that goes into much greater detail, that goes down to the electrical details, the power details, structural details, environment details, everything that you might want to need to know in development and design for your payload. And then you can also use our CAD file to integrate. So I saw a couple of uses of that today. It was really exciting to see some payloads attached to that. I saw a drill, at least one of those. And then we also have payload managers that work at the company that interface directly with the customers. So you will be assigned one of those when you get on board, and that person is your liaison all the way from contract signing through launch. That they are there on your behalf inside of our company, making sure your interests are represented and make sure we're supporting your payload properly from the get-go. So we are really excited to be carrying payloads from all over the world back to the surface of the moon, and incredibly excited for our first mission in July of 2021. And we invite all of you to join us on future missions, and I look forward to a long, thriving relationship with the science community. Thank you, guys.
Questions?
Hi, Dov Rhodes from NASA Goddard. I was just curious about that neat little line you drew at the end with the path optimization. Did you just do that by hand, or do you have a methodology for that?
Oh, no. It's not by hand. Let me see if I can get the video to go again. So what this is, we have models of where the sun is, where the Earth is, and we create maps. And then we have an autonomous path planner that lays on top of that. So you put your science areas of interest, say I want to go over here, I want to go over here, I want to go over here. And then it combines your interest areas with those resource maps to draw a line and tell you where to go. So sometimes you need to move fast, sometimes you need to move slow, sometimes you need to just sit and stay in the light. So there's ways that you can extend missions at the poles of the moon for substantial time. So this one's a 48 Earth day traverse, and if you were just sitting in one spot, you might get maybe a week or less of power at this particular location.
All right.
Great.
Thanks so much.
Thank you.